In this video, we will continue our midterm 1 review and look at some graphing 3D objects examples. All right, so here's the example. Let's graph and describe the following 3D objects. Okay, so we're going to want to graph this and we're going to want to describe it in words. So part A is we have x squared plus z squared is less than or equal to 9, along with y is less than or equal to 0. So we want to graph the object that's described by these two inequalities, these two joint inequalities, and then describe it in words. Okay, so let's start by looking at this first inequality here. So we have x squared plus z squared is less than or equal to 9. There's two things I want to observe about this. So, actually, before we do that, let me give you the chance to try this. So pause the video for about 2 minutes and try this problem. 4, 3, 2, 1, pause the video. Pause the video for about 2 minutes to try this question. So hopefully you've done that. Hopefully you've paused the video to try this. If not, go ahead and do that now. So let's go ahead and talk about it together. So the first thing I want to observe about this first inequality is, well, what does that less than or equal to mean? So less than or equal to means that x squared plus z squared can equal 9. It can equal 9 and also be less than 9. Okay, so both of those are important. So let's think about what both of these would tell us. So when x squared plus z squared equals 9, this equation reminds us of a circle. It looks like a circle equation. And the center of the circle, so the center of that circle would be, so the x-coordinate would be 0. The y-coordinate, let's skip the y-coordinate for the time being. And then the z-coordinate would be 0 as well. So the y-coordinate of the center, based off of our two inequalities here, we know that y can be any number that's less than or equal to 0. So there's a bunch of possibilities. So I'm just going to keep that as y right now. For the center, I'll just assign a variable to it. Well, let's say what the radius is. The radius is square root of 9, which is 3. And the other thing that I can say about this circle is, what direction is it sort of in? Well, it's parallel to, because this equation, or sorry, this inequality involves x and z, it's going to be parallel to the xz plane. All right. When x squared plus z squared is less than 9, we would be looking at the stuff inside that circle. All right, so that's what the inequality is going to tell us. So just from that inequality, we got a lot of information. And the second thing I want to observe about that first inequality, is that y is free in the inequality. And that means y is going to get to be anything. Well, not quite anything. It's going to be dictated by this second inequality. The second inequality will tell us exactly which values of y are going to be allowed. But we want to keep in mind that we have this flexibility when it comes to y. All right, so now let's try to begin graphing this. Okay, so let's draw some axes. So let me draw the z-axis going up, x-axis coming out of the page, y-axis going to the right. And then I'll draw, z and then negative direction. So negative z direction, negative x direction, negative y direction. Okay, so let's try to graph this thing first. So let's try to graph this circle that we have here that has a center of 0, y, 0. But I'll graph the circle where the y-coordinate is 0 first. So that would be the circle that lies exactly on the xz plane. Okay, so that would be a circle that lies exactly on the xz plane with the center at the origin. It looks something like this, where it goes 3 in this positive x direction, 3 in the positive z direction, and the center is right at the origin. So that's one of the circles that's being described by this inequality. But of course, there are many other circles that are being described by the inequality. In fact, I could take a circle that has a center somewhere over here with a negative y value, and I could draw that circle. So I'll draw that circle, and I'll put a dashed line for the backside, because the backside actually won't be viewable to me as I start to sketch this out. But I'll get a bunch of these with different center points all along here. So now I'm going to start to connect these. So start to connect these, because y could be anywhere going in this negative direction. So we could be anywhere on this surface. So this surface is starting to look like a cylinder. But also, because of the less than part, we could be inside. So we could be anywhere inside of this disk right here. But also, we could be anywhere at all of these values. Anywhere at all of these values. And that is what the graph of our region looks like. So writing that in words, I might write the object consists of all points on and inside. On and inside, what does this shape look like? Well, it's part of an infinite cylinder. An infinite cylinder with a circular base. So by the base, I'm going to talk about this part of it right here. Circular base with center. So the center of that circle happens to be 0, 0, 0, the origin. R is equal to 3, that's the radius of that base. And what direction is that on? Or is that in? Well, I can actually say that that circle is on the xz plane, precisely. Okay, so we're talking about an infinite cylinder. We could be anywhere on, and we could be anywhere inside that infinite cylinder. Okay, that has the circular base. And then what direction is that cylinder going in? Well, that extends infinitely in the negative y direction. And that would be my description in words. So it's a little bit flexible in terms of what you write here in your description. You just need some words, some way of describing what this object looks like as precisely as we can. So having the picture and having this description in words is what we were looking for in this problem. All right, so that was part A. Now let's do a part B. Part B is, I have the same first inequality, x squared plus z squared is less than or equal to 9, but now the second inequality changes to an equation, y equals 0. So pause the video, this time for just 1 minute, and think about how this one will be different. 4, 3, 2, 1, pause the video. Pause it for about 1 minute to try part B. All right, so hopefully you've done that. Hopefully you've paused the video for about 1 minute to try part B and think about how it's different from part A. It's probably wasn't enough time to finish the question, but that's okay. I mostly want you to think about how you'd begin. All right, so because we have that same first inequality, the inequality is what sort of gave us this infinite cylinder and also the inside of the infinite cylinder. When y was less than or equal to 0, that told us, well, we can't go in the positive direction. So we can't go in the positive direction because y was less than or equal to 0. We were restricted to being at 0 or in the negative direction. When we have this equation, it means we are actually going to take part of the graph in A where y equals 0. So y needs to exactly be equal to 0. So let's draw that first. Let's draw our axes. So x, y, and z. Let's zoom it out a little bit so we can draw it. Negative z, negative x, negative y. So if y needs to exactly be equal to 0, that means we are only allowed to be on this base circle right here, where the z goes up to 3 here, x goes up to 3 there. So we're only allowed to be in this circular disk. I can be on it because I have x squared plus z squared equals 9, and I can be inside it because it's allowed to be less than 9. So in words, we say the object consists of all points on and inside a circular disk with center. In fact, maybe it's slightly better to say either on or inside. So on or inside, even up here, let's change that to on or inside. Because I could be on the exterior surface of the thing, or I could be inside it. Either one of those is fine. Okay, so back to the description. Disk with center 0, 0, 0, radius equal to 3, and it's on the xz plane. And there is our description in words.